Hello, and welcome to Arcadia University's BI327 Histology course. This is the lecture series on epithelial tissues, and in part 3 of this lecture, we're going to take a look at epithelial classification. Now, epithelial, as we said, is a tissue that's going to be forming a sheet along surfaces of the body. And so we need to have a way in which we can go through and classify the epithelia. And there are going to be two basic criteria that we're going to use. The first is going to be the number of cell layers, and the second is going to be the shape of these surface cells. Okay, so if we take a look at the number of cell layers, it's going to be relatively simple. If it's a one cell layer thick epithelium, so essentially just one layer, it's going to be referred to as a simple epithelium. And if it's greater than one cell thick, whether we've got 2 cells thick or 100 cells thick, it's going to be referred to as stratified because we're going to have different layers of cells stacked on top of one another. Now, it gets a little bit more complicated in that there is a specific type of epithelia that we'll see later on in the course, which is pseudostratified. Now, if we take a look at pseudo for false, stratified, it's falsely stratified, which means that we're going to be looking at something that's one cell layer thick, but it looks like it's going to be multiple layers. And the reason for that is that all of the cells are sitting along the basement membrane, but not all the cells reach to the apical surface. And so because of that, it has the appearance that the nuclei are stacked because you're going to have nuclei at different levels within the epithelium. And normally, we can use the nuclei to give us a lot of information for where the cells are going to be located. But with the pseudostratified epithelia, it becomes a little bit more difficult because it's still going to have that stacked appearance, even though it's not truly a layered epithelium. So we take a look at the number of cell layers, and then the second criteria is going to be the shape of the surface cells. And again, that's relatively basic. We're going to take a look at it. If the cells are very flat and scale-like, they're going to refer to as squamous cells, almost like little scales in essence. So squamous cells, flat, scale-like. And then we take a look at cells that are built a little bit larger. If the cells have about the same width and height, they're basically box-like cells. They're going to be same width, same height. They're going to be little cubes. And so we're going to refer to them as cuboidal cells. If they're taller than they are wide, if they got more height than they've got width, they're going to be columnar cells because they're going to be looking like little columns. Now, if we take a look at the nuclei of these cells, again, getting information from the nuclei, the squamous cells are going to have kind of flattened nuclei that are running down along the length of the epithelium. The cuboidal cells are going to have rounder nuclei. And in general, the columnar cells are going to have oval nuclei with the long axis of the oval running along that height of the cell, the long axis of the cell. So those are the most common types of cells, but we also have one additional shape that we need to keep in mind, and this is going to be a transitional epithelium. The transitional epithelium, the surface cells are going to be large, ovoid, but the shape can change depending upon what's going on in the region. We see these transitional epithelial cells in the bladder, which is going to be subject to stretching. So from this information, we can get an idea how we're going to classify the epithelium, but I also want to emphasize again that relationship between structure and function, between anatomy and physiology, as we're taking a look at the epithelia and taking a look at the different characteristics. In general, when we're taking a look at either a simple or pseudostratified epithelia, so in essence one cell layer thick, whether it looks that way or not, we're generally going to be involved with things that have involved with movement across the membrane, and generally secretion or absorption, with the height of the cell, the taller the cell, generally indicating more and more secretory and absorptive activity. Now there's a little bit of an exception to that, in that if we have a simple squamous epithelium, we're going to be looking at transepithelial transport, essentially movement across that epithelial lining with a minimum amount of processing, without a lot of secretion or absorption going on. Basically, it's passing through it relatively easily. So simple epithelia are going to be involved with movement of materials across the epithelial lining. Stratification, or multiple layers of the epithelia, is going to be generally associated with transepithelial impermeability, so preventing things from passing across the membrane. And again, this is just a rough kind of generalization, but it'll give you an idea that we can take a look at these epithelial cells and begin to understand how the structure relates to the function that they have. So the next thing we're going to do is put together the two parts, the number of cell layers and the shape of the surface cell, and look at some basic basic types of epithelia. The first are going to be the simple squamous epithelia. So simple, one cell layer thick, squamous, flat plate-like cells. Okay, so we're going to have a very thin epithelium, and so we're going to find this in areas like the endothelium, which is going to be the lining of blood vessels, mesothelium, which is going to be the lining of the body cavities, as well as an area like the parietal layer within the renal corpuscle. And we'll talk about more these in detail as we're going through with the course. The second epithelia we'll look at are going to be the simple cuboidal epithelia. Simple for a single cell layer thick. Cuboidal, so they're going to be cubes. They're going to have about the same height and width, and in general they're going to have kind of rounded nuclei. When we take a look at regions of the body that have a simple cuboidal epithelium, we're going to find that they're forming conduits or duct systems, generally for carrying secretory or excretory products. So lots of ducts of the body are going to be lined by a simple cuboidal epithelium. Sweat gland ducts, kidney tubules. We're also going to find this simple cuboidal epithelium as a protective mechanism along the free surface of the ovaries. Moving on, we've got the simple columnar epithelium. So simple, one cell layer thick. Columnar, they're taller than they are wide, so they're like little columns. As we said, they're generally going to be involved with secretion or absorption. And so we can see a simple columnar epithelium in areas of the digestive system, like the stomach, the small intestines, the rectum, the gallbladder. We can see it in some specific kidney tubules. We can see it within glands within the uterus. And we can also see a simple columnar epithelium in some of the larger ducts within the body. Now, many times we're going to find apical specializations along these simple columnar epithelium cells. So one example of that are the microvilli. We've talked about those already in the course. Microvilli, with their actin core, are finger-like projections that increase the surface area for absorption. And so this is going to be very prominent when we take a look at the simple columnar epithelium within the small intestines, because we want a lot of surface area for the absorption of nutrients within the small intestines. Another example of that, simple columnar epithelium with specializations, apical specializations along the surface. We have simple columnar epithelium with cilia. Now with cilia, again, finger-like projections, but instead of microvilli with an actin core, cilia have a microtubule core. And again, microtubules are going to be capable of movement, and so the cilia are going to be able to be beat in waves, and they're going to be specialized for propulsion of materials across the surface of the epithelium. And so we can see this within the oviducts. So simple columnar epithelia with cilia along the surface are going to be beating to move the ova, the eggs, along the oviducts. The next one we're going to look at is going to be the pseudostratified columnar epithelia. So if we think about it, pseudostratified, falsely stratified, what that means is all of the cells are going to be sitting upon the basal lamina, but not all the cells reach the apical surface. So what that means is the cells that are kind of short in essence and don't reach it to the apical surface, their nuclei are going to be trapped down towards the basal portion of the epithelia. The cells that are a little bit taller are going to be able to squeeze a little bit further up into the epithelium towards that apical surface, and their nuclei are going to be higher up within the epithelium. And because of that, it's going to look like the nuclei are stacked on one another. But in essence, all of the cells are going to be reaching down to the bottom, but not all of them reach up to the apical surface. A couple locations where we can find a pseudostratified columnar epithelia. If we find cilia along their surface, it's going to be the classic epithelia that we're going to find in the upper portions of the respiratory tract. It's referred to as a respiratory epithelium because the cilia are going to be beating to propel the mucus that carries the trapped debris, the material that's breathed in that could be potentially harmful to the respiratory system, gets trapped in the sticky mucus, but then the cilia propels that so that it doesn't accumulate within the respiratory system. We can also find a pseudostratified columnar epithelia with stereocilia along the surface. Again, stereocilia, again, like a long microvilli in essence. They're going to have an actin core, non-motile. but we would find a pseudostratified columnar epithelia with stereocilia within the male reproductive tract, within the ductus epididymis. Now as we move on into the stratified epithelia, we're going to see the first example is going to be the minimally keratinized stratified squamous. And so stratified, meaning we've got multiple cell layers, and in this case we've got many cell layers that can be present. Squamous, meaning that the surface cells are flat. And we're going to look at another example of a stratified squamous region of the body, tissue of the body, on the next slide. But in this case, we're looking at minimally keratinized. Okay, so keratin, as we described previously, is an intermediate filament. It's going to be involved with the cytoskeleton. It's going to be involved with strength within these cells. And minimally keratinized means we've got a little bit of that there, and it's not its most stable form in essence. And we're going to see nucleated cells along the surface. Okay, so what this means is that we can find a minimally keratinized stratified squamous epithelium in regions of the body that we basically have a moist cavity that's going to be subject to abrasion. So we need lots of cell layers so that we don't damage all the way through the epithelium and damage the underlying tissues. And so the minimally keratinized stratified squamous epithelium is often referred to as a mucous membrane. And we can find it in regions of the body with a moist cavity subject to abrasion, like the mouth, the esophagus, the anal canal. We can find it lining the vagina. We can find it lining the inner surface of the eyelids. So again, it's going to be a relatively resistant form, but we've got nucleated or living cells along the surface. So it's minimally keratinized because we're exposed to that moist cavity. In contrast, the maximally keratinized stratified squamous epithelium, same basic setup, stratified, multiple cell layers, in this case many, many cell layers, but the surface cells are still going to be squamous. They're still going to be flat, but they're going to be enucleate. They're essentially going to be dead. And these are maximally keratinized, meaning that those surface cells are going to be packed with keratin, packed with this very resistant, very strong cytoskeletal element. And that's going to give us a strength to that outer surface of the skin. So what we can see then is that this is going to be very good at a resistant boundary along the surface of the skin, because you don't want to brush up against things and have damage to your epithelia. So it's protection against friction, abrasion, protection against infection, protection against water loss, because we're against that or exposed to that external world, that dry world. So we're going to have dead cells along the surface because they can't survive. They're going to dry out. So we're going to have mechanisms, which we'll talk about later on when we talk about the skin as an organ, that provide these properties, these protective properties. So again, maximally keratinized, lots and lots of keratin, stratified squamous, many cell layers, surface cells are going to be flat, but they're going to be flat and dead. They're going to be enucleate cells. So we essentially have cell remnants packed with cytoskeleton along the outer surface of the skin. And then finally, we're going to take a look at stratified cuboidal and stratified columnar. Now, these are much rarer within the body. Stratified meaning multiple cell layers, usually 2, possibly 3 cell layers thick. And the surface cells are either going to be cubes, about the same height and width, or columns, so taller than they are wide. Relatively rare, lining some ducts within the body, but in general, not found very commonly within the body when we take a look at it. And then finally, we've got the transitional epithelium. The transitional epithelium kind of breaks some of the rules. Doesn't give us the stratified that we had before in the previous version. But we know transitional is going to tell us that we're looking at a stratified epithelium. The surface cells, generally if we've got many, many cell layers thick, we're going to normally be thinking stratified squamous, either minimally keratinized with nuclei, flattened nuclei along the surface, or maximally keratinized where we have enucleate or dead cells along the surface. Transitional cells, we're going to have nucleated cells along the surface, dome-shaped cells, rounded nuclei, occasionally binucleate cells, cells with 2 nuclei. And again, these are going to be locations in the body where the epithelium is going to be subject to stretching. And so we'll see a transitional epithelium lining the bladder or lining the ureter. As always, if you have any questions, feel free to email me at hoffmanj@arcadia.edu. Thanks, and I'll see you at part 4 of this lecture.